In this video, I'd like to talk about finding missing angles using equations. So with these example problems, we are going to be given some different angles and expressions relating those angles. And we need to figure out how to set up an equation so that we can solve for the missing variable and then find the measure of one of these specific angles. So with this example problem, the angle measurements in this diagram are represented by these two expressions. And we have this diagram marking A and B, but we're also told that this line here and this line here, these are going to be parallel lines, since we use these arrows to represent that they're parallel. They each have two arrows. So after highlighting the fact that these are the parallel lines, and this line here, we call this the transversal. It's the line that cuts the parallel lines. We can now relate them using the properties of parallel lines. So angles A and B, notice these are corresponding angles. And with parallel lines, corresponding angles are equal to each other. In fact, they visually look equal to each other, though I do want to warn you by just going by the picture, since sometimes the picture is not drawn perfectly. But you can roughly see that these do look equal. But in general, with parallel lines, when you have corresponding angles, so maybe if we called this angle C, then the corresponding angle to this would be right here, which we can maybe call D. So corresponding angles in parallel lines are always equal. So we can say that angle A is equal to angle B, since we can say A and B are corresponding angles. And keep in mind, we can also use other properties of parallel lines if we need it in later problems, that since we know vertical angles are equal, so this angle opposite angle A is also equal to angle A. So this is A as well. And notice that since we know A and B are already equal, that this angle here and this angle here with parallel lines, these are equal. We call these alternate interior angles. And since we know that this large angle forms the angle of a line, and this is a vertical angle, so this would also be angle C, and we know angle B and angle A are equal to each other, then we can know that C plus B, these also would form the angle of a line, or in other words, they would be supplementary. And again, that's just because A and C are supplementary and A and B are equal. So therefore, B and C would be supplementary as well. So those facts will come up in later problems, but for this problem, we just need to know that A and B are corresponding, and so therefore they are going to be equal angles. And with that information, we can set up an equation. So let me just make a little bit of room here. But we're going to set this expression for angle A equal to the expression for angle B. So angle A, we know that is just 5x minus 5 degrees. And angle B, which angle A is equal to 3x plus 13 degrees. So let's solve this equation for x, and then we can plug x back into this expression for b to find the actual angle measure for b. So let's first get the variables on the same side of the equation. So since there are variables on both sides, we want to move them all to one side. And you can move them to either side, but generally, if you move them to the side with more of that variable, 5 is greater than 3, then you can often avoid negative numbers. Most of the time you can. So we want to cancel out this 3x and move it over here. And since this is a positive 3x, we can use subtraction on both sides to cancel that out. And 5x minus 3x, that's just 2x. We still have the minus 5 degrees. 3x minus 3x, that's 0, so those cancel. And this is just equal to 13 degrees. And now that we have the variables on one side of the equation, we can solve for x, since this is now just a two-step equation. And we want to cancel out subtraction first, since canceling out addition and subtraction are simpler than canceling out multiplication and division. So subtracting 5, we cancel that with adding 5, doing the opposite. So this just becomes 0. So we get 2x is 13 plus 5, which is 18 degrees. And lastly, we want to cancel out that multiplication by division. And 2 divided by 2, that's just 1, so we get 1x, or just x. And over here, we have 18 degrees divided by 2, which is 9 degrees. So let's now plug this into our expression for b. So working down here, we know that, or we think that, x is 9 degrees. So angle B then would be 3 times 9 degrees plus 13 degrees. 3 times 9, that is 27 degrees. And adding 13 more brings us to 40 degrees. Now, one way to check this is to also plug x into angle A and make sure that also equals 40 degrees. So let's do that. We are also plugging in x is 9 degrees, so we get 5 multiplied by 9 degrees, and we'll take away 5 from that. So that's 45 degrees, and again, this is angle A. We have 45 degrees minus 5 degrees, which is 40 degrees. So we got the same value, which we should expect since they're corresponding angles. So this just gives us a little bit more confidence that this is in fact the correct answer.